So this one is a very difficult question, okay? But it's difficult because it has a lot of things to do, but the idea is simple. So it's saying that how many lattice paths from 0, 0 to 10, 10 that pass through 3, 3 but not passing through 5, 5. Wow. How many way this one will passing through this guy, but not passing through 5, 5 and reach 10, 10. So first, 0, 0 to 10, 10 that must pass through 3, 3. That means 0, 0 to 10, 10 that must pass through 3, 3. Then we consider 0, 0 to 3, 3 and then 3, 3 to 0, 0. Okay, so this is the same as consider 0, 0 to 3, 3. What is this? This is not cross. This is Cartesian product. This is the set, okay? And then what? And then we need to have 3, 3 to 10, 10 that not passing through 5, 5. Okay, we just write it down like this first. Later we will deal with this guy. Then for the yellow part, 0, 0 to 3, 3, we know that
from 0, 0 to m, how many way? M plus n, m.
So now we replace m, n by 3, 3. That means we have 3 plus 3, m is 3, so 3. So that means this yellow part have this number of ways, okay? So this is the yellow part. Then now the next thing is, how do we deal with the red part? Okay, so this is the red part. The red part is saying that we want to move from 3, 3 to 10, 10 that do not pass through 5, 5. So 3, 3 to 10, 10 that do not pass through 5, 5. So first what we do, we perform a coordinate transformation. We shift everything to 0, 0. So we minus everything by 3. So 3, 3 minus 3 is just 0, 0. 10, 10 minus 3 is 7, 7. 5, 5 minus 3 is 2, 2. This is basically shifting coordinate. So that's why we get this one. So now with this red thing, we are now going to do complement rule. So that means from 0, 0 to 7, 7 not passing through 2, 2. Then we just count all the way that what? All the path from 0, 0 to 7, 7 that pass through 2, 2. Okay, so here's the idea. Okay, complement rule. 0, 0 to 7, 7 that do not pass through 2, 2 is the same as all the path from 0, 0 to 7, 7 minus all the, okay, so what does mean all the path? All path means 0, 0 to 7, 7, okay? Minus all the paths from 0, 0 to 7, 7 that pass through 2, 2, okay? Then, what's this? 0, 0 to 7, 7 that pass through 2, 2 is the same as what? It's the same as 0, 0 to 2, 2 and then 2, 2 to 7, 7 product rule, okay? So, that means the green thing, 0, 0 to 7, 7 pass through 2, 2 is this green thing. 0, 0 to 7, 7 that pass through 2, 2 is the same as 0, 0 pass through 2, 2 and then 2, 2 to 7, 7. Okay, this is what I mean the product rule, or this dot, okay, or Cartesian product. Okay, what's the idea behind? Let me recap. 0, 0, 7, 7, 2, 2. So again, we want to study how many ways that this point will pass through here and then this point will pass through here. Then we just consider this region and this region. Okay, so how many ways from 0, 0 to 2, 2? Well, just this. How many ways from 2, 2 to 7, 7? Just this. So that means we use the product rule to deal with the green thing. So now, then that's all. Now we can look at how we proceed the whole problem. So first of all, what? We want to study 0, 0 to 10, 10 that pass through 3, 3 but not 5, 5. So we first split the problem. 0, 0 to 10, 10 must pass through 3, 3. So we study 0, 0 to 3, 3 and 3, 3 to 10, 10. So that's why first we have this thing. These two things. Okay, so this is 0, 0 to 5, 3, 3. And then 3, 3 to 10, 10. We have a condition here that do not pass through 5, 5. We will deal with it later. Then with this is Cartesian product. So Cartesian product for the cardinality, we reduce this to product rule. So this is product rule. We have a dot here. So we move from this line to this line. Okay. Then from this big expression here, okay, from this big expression here, the green line here is this green thing. Okay. This is by formula. Okay. What formula? 0, 0 to mn is have this number of way. So this green thing have this formula. Then what about the second bracket? The second bracket is we are doing complement. 0, 0 to 7, 7 that do not pass through 2, 2. Then what is it? It is same as 0, 0 to 7, 7 minus 0, 0 to 7, 7 that pass through 2, 2. Okay? So we have to compute this, and then we take subtraction. So again, what is this guy? 0, 0 to 7, 7, we know the formula, so we can have this. Now we need to deal with the blue thing. Okay, the blue thing. So what's the blue thing? The blue thing is 0, 0 pass through 2, 2 to 7, 7. So 0, 0 go to 7, 7 that pass through 2, 2 is the same as 0, 0 go to 2, 2 and then 2, 2 to 7, 7. Okay, and this is what? Cartesian product. Cartesian product, you use product rule. Okay, then you have this. Then what's this? You have the formula, right? So you have this thing. And then what is this? This is same as 0, 0 to 5, 5, right? So we have this. So finally, we combine everything. We get this. Okay, so that's the answer. Okay, so this is the number of way from 0, 0 to 10, 10 that must pass through 3, 3 but not 5, 5. Okay, in this example, we have made use of number 1, the formula, this formula. Number 2, the idea about Cartesian product and product rule in combinatorics. Number 3, we have made use of the idea of complement. That means the logic of logic not, okay? And then we just repeatedly using this trick again and again and again to derive this solution. And if you try to solve this by brute force, it will take a lot of time because you can see this number is very big, okay? So, yeah. And lastly, so in 2-dimensional space, the lattice has this formula. What about in 3D cube? We just add one more number. So from 0, 0, 0 to MNP, it will have this formula. And this is what? This is trinomial coefficient. So for example, from the point 0, 0, 0 to the location 2, 2, 2, it has 90 weights. So that means if you draw the line, you have 90 of them. And this kind of number grow very fast, okay? And of course, I can ask a similar question. How many lattice paths from 1012 to 555 that must pass through 333 but not 123? Oh, this is already very complicated. And I can generalize, for example, from 0, 0, 0, 0, so this is an n-dimensional vector from to this point. N dimension is this thing, which is basically k1 plus k2 plus up to kn, which is a very big integer. And then what? We have a k1 factorial, k2 factorial, blah, 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 until kn factorial. 2-dimensional problem may appear in the assignment or test or exam, but 3-dimensional or n-dimensional won't appear in exam, okay?